Hi, I'm John. I'm team captain of Team 1, and we're here to present the IE 4305 machine learning project. Next, I'll introduce you to Sam, who will be doing the goals of the project.
Hey guys, my name is Sam, here with you with the purpose and the goals of the project. We have two goals, and our goal is to identify a machine learning model that best predicts a set of target variables for both the continuous data set and the categorical data set. Next, I'm going to introduce you to Eric, where he's going to run you guys over the continuous data set.
Thanks. So our continuous data is sales data from Walmart. Uh, so this data set collected the data of total number of sales from several Walmart locations over a long string of time. And the core concept of the set is to compare those sales points with various variables such as the unemployment rate in the surrounding area, the consumer price index at the time, the fuel prices in the area, the current outside temperature even, and just the date. All of these expected to be correlated with sales, affecting it positively or negatively. And additionally comes with a special acknowledgement of holidays, which will, as we all know, holidays will directly massively increase sales at any grocery store, and so those would cause unexpected disruptions if not accounted for. Next up is Yanita to talk about the methods we used.
So starting off with the data preparation, no columns were dropped for this data set and there was no missing data in any of the rows. And so the date column was split into weekday, months, and years just to be able for the data analysis later on to work properly. And the store column was changed into 45 dummy columns, just using the one hot encoding to use the binary variables to show which store's data was being represented on each row. And then moving on to the pair plot, the diagrams in the diagonal of the pair plot show skewed histograms, which just means that most of the data or most of the variables were clustered up into one side. And for CPI and fuel prices, they had bimodal distributions, which pretty much just means that there was two different clusters in the data. And the scatter plots surrounding the diagonal histograms show there was nonlinear association between the variables. And then moving on to the next slide. For the probability density function for the weekly sales, we can see a rightly skewed data histogram. And what that means was the weekly sales were clustered up in the lower end rather than the higher end. And moving on to the correlation heat map, we can see that the highest correlation was between fuel prices and years. And when looking at the overall correlation, there was really a weak correlation between the variables. And then later for further analysis on the data set, the data was split into an 80-20 ratio to remove bias towards the different data characteristics and was then standardized to have the split perform correctly. And then moving on, John will describe the methods and models.
So our first model is the multiple linear regression. Here's the equation. Y is the target variable, that is the weekly sales. B0 is a constant. Bn is the coefficient of the predictor variables. Xn is the predictor variables themselves. Epsilon is the estimation error, but that's usually assumed to be 0. And when it's run through Python, the output evaluates the significance of each coefficient, and that uses the p-value or the F statistic. Next is a decision tree regression. So all the data starts from the parent node, and it splits into child nodes with different homogeneous sets of data. And it keeps splitting from all of the other nodes all until the data becomes pure. So you can see on the right, there's a decision tree we used for our model. Next is the random forest regression. This is an ensemble style of machine learning, so it uses multiple decision trees. Random data is fed into each of the different decision trees, and then the outputs from the decision trees are averaged out into the final output. So you can see on the right, there's a diagram of a random forest regression. And next is results. On the top left is the multiple linear regression. The center bottom is the decision tree regression, and the top right is the random forest regression. Judging by the plots, it seems that random forest regression is more accurate and more precise than the other models. Next is the evaluation metrics. So we use 3 metrics to judge our models. So first is the mean squared error. That measures the error between the actual and the predicted values. And this metric usually punishes models that have larger errors. So we also use the root mean squared error, which uses the square root of the mean squared error. And it's also more commonly used. And finally, we use the R-squared value. That represents the percentage of data explained by the model. So in the table in the top, the random forest regression also wins in terms of metrics. So next is Taylor with the Titanic intro to the dataset.
Thanks, John. For our categorical research, we studied the Titanic passenger survival dataset. Understanding the intricacies of the tragic incident of the sinking of the RMS Titanic requires a comprehensive analysis of various socio-demographic factors. The study delves into the categorical dataset detailing the passengers aboard the Titanic, aiming to unravel the complex connections influencing individuals' chances of survival. Factors such as ticket class, the survivors, passenger gender, age of passenger, number of siblings or spouses, and parents or children were examined to shed light on the dynamics during the significant historical event. We utilized advanced machine learning algorithms to analyze hidden patterns and relationships within this data set, and Mark will now speak on the data preparation.
Thank you, Taylor. So for the data preparation stage, there were 5 columns that were dropped due to being deemed irrelevant to the chance of survival. These 5 columns were passenger ID, name, ticket, cabin number, and the location where the passenger embarked from. Therefore, the clean data set contained only 7 columns, which included whether or not the passenger survived, the passenger class, the sex, their age, SIB-SP, which is the number of siblings divided by spouses aboard the Titanic, the PARCH, which was the number of parents divided by the children aboard the Titanic, and last of all, the fare. Next, we identified that there was 177 null values for age, which were filled using the mean age value for the variable. Next, the data type for sex was converted from a string to integer, with 1 representing male and 0 representing female. As for the descriptive statistics, the mean for survival rate of passengers was 0.38, indicating that there was a low chance of survival. Additionally, the mean sex was 0.65, which meant that a larger proportion of passengers were male. However, this could be attributed to the fact that a large majority of the crew were male, with only 22 female and 896 male staff. Next, the mean fare for the Titanic was 32.2, but the standard deviation was 49.7, which indicates a large disparity in the economic class of passengers. Next is the pair plot for the data. Looking at the scatter plot shows that multiple variables have no correlation between each other, as they either have a vertical or horizontal line of best fit. And when analyzing the histogram, the data has a bimodal distribution between male and female. However, the histogram indicates that a larger number of passengers that did not survive were male, while more passengers that survived were female. And as for the probability density function for age, it resembles a normal distribution with many passengers near the age of 30. This indicates that a large number of passengers who could afford to board the Titanic were within their 30s. And next, I'll be passing it off to Christian to discuss the models and methods used.
So for our models and methods, for our categorical data set, we use logistic regression and neural networks. For the logistic regression, we had a confusion matrix, which has two values, either being positive, which means they survived, or negative, meaning that the passenger did not survive. It outputs a square matrix with a number of samples for the true positive or negative value, which means the model correctly predicts a positive or negative, or a false positive or negative, meaning that the model predicted it was either positive or negative when it was actually the other way around. And we can use a heat map to visualize the confusion matrix. We use those values in a classification report to get the accuracy, precision, recall, and F1 score of our model. And we want our model to have a very high value for each of these. We also used a ROC curve, which plots the true positive rate against the true negative rate. The area under the curve indicates how well the model performed at distinguishing between true positives and negatives. The larger the area under the curve, the greater the performance of the model. So an area of 1 would mean the model is 100% correct in its predictions. We also had a logistic regression summary, which outputs a table giving coefficients, standard error, z-score, and p-score for the model. We can use the coefficients to determine the correlation between the independent variable and the dependent variables. And then we can use the p-score to determine how statistically significant our correlation is. For our neural networks, we used Keras. A neural network is a mesh of different layers with weights placed on them that are then stacked together to create a model. There are nodes in each of these layers that a portion of the data is passed through to get an output, which is then compared with known values in the data. The neural network then learns from its mistakes and retries whatever it was learned. And then each retry is called an iteration. For each iteration, the model is continuously improved. SHAP, or Shapely Additive Explanations, uses game theory to explain the output of machine learning models, which can then be visualized using a summary plot. And then moving on to our results slide. For our logistic regression, we have our confusion matrix, which shows that we have 94 true positive values, 49 true negative values, 12 false positives, and 24 false negative values. And then our classification report gives us a bunch of output for the precision, recall, accuracy, and F1 score, and they're all very high. So our model is really good. For our ROC curve, we have an area under the curve of 0.85 or 85%. So our model has really good performance. In our next slide, we have the logistic regression summary. When looking at the p-values for each of the dependent variables, we find that the p-class, age, and parch are not statistically significant, while sex, fare, and sibling spouses are. When looking at the coefficients for each of the statistically significant variables, we found that there's a large negative coefficient for sex, indicating that females are more likely to survive than males. We found that there's a positive coefficient for fare, indicating that passengers that paid more are more likely to survive. And we find that there is a negative coefficient with sibling spouses, indicating that passengers with more siblings and spouses are less likely to survive. Then we have our neural network model. So when looking at our neural network model, we found that our model loss is only 14%, and we found that the training and validation lines closely follow each other. As the model iterates, the model loss decreases, showing that it's improving through each iteration. And for our SHAP plot, for the neural network, it shows us that passengers are more likely to survive if they have a low passenger class value, so it'd be first class and second class, and if they have a low sex value, meaning that they're female. Parch, age, and sibling spouses are mostly neutral, with parch and sibling spouses favoring higher values and age favoring lower values. I'll now pass it off to Bishoy for the conclusion.
Thank you. For our conclusion, in this project, we conducted a comprehensive analysis using machine learning techniques on two distinct data sets. The first data set will be the historical data sets from the RMS, Titanic, and the Walmart data set. By examining the Titanic data sets, we identify crucial factors like gender and ticket class that significantly influence survival rates. We explored how various economic factors such as unemployment rates and gas prices impacts sales trends in Walmart stores. We utilized advanced algorithms, including random forest and logistic regression, to derive these insights. The findings not only provide valuable perspective for historical research and retail decision-making, but also demonstrate the potent capacity of machine learning to enhance data-driven strategies across different fields. And thank you.